Welcome, my dear learners, to today's episode on the Video channel. In today's lesson, we shall be looking at substitutions and the logarithms. In this aspect, an estimated value of a logarithmic number will be given, and we will be asked to evaluate other logarithmic expressions using the estimated number given. Now, what I mean is this. Given that log of 2 to the base of 10 and the estimated value for this is 0.3010. Now you'll be asked to evaluate other logarithmic expression. Let's say log of 8 to the base of 10. So you want to evaluate this logarithmic expression using the estimated value for this log. So to solve questions of this, what we have to do is to express this logarithmic expression in a form of log of 2 to the base of 10 so that we can do the substitutions for that. So this is what we are going to do. Now we know that 8 can be written in an index form as 2 raised to the power 3. So we are going to write this as log of 2 raised to the power 3 to the base of 10. So applying the power law of logarithm, the power will come in front to multiply the logarithm. So you will have 3 multiplying log of 2 to the base of 10. So at this real point, you realize that we are having log of 2 to the base of 10. So in place of log of 2 to the base of 10, which is this one, we are going to substitute the whole of this. So you have 3 multiplying 0.3010. So this is what we will be doing in this very lesson. Substitution. So let's look at our first example to see how best we can approach questions of this nature. Given that log of 2 to the base of 10, this is the estimated number, and then log of 3 to the base of 10, the estimated number is 0.4771. We want to evaluate log of 0.24 to the base of 10 using these two estimation numbers given to these logarithms. So before we can solve questions of this nature, then we need to express log of 0.24 to the base of 10 in either log of 2 to the base of 10 or log of 3 to the base of 10 so that we can do the substitution for that. So we have to express log of 0.24 to the base of 10 in either this or that. So let's continue. So we have log of 0.24 to the base of 10. We know that 0.24 can be written in the fraction form as 24 over 100. So we have So from here, we can apply the division law for logarithm. So this is the division law for logarithm. When you have the logarithm of two numbers dividing themselves, then we have to subtract the logarithms of these two numbers. So you have log of 24 to the base of 10 minus log of 100 to the base of 10. So at this very point, you realize that we are still not having log of 2 to the base of 10 or log of 3 to the base of 10. So we have to simplify further in order to obtain one of these. So we shall have log of, you know that 24 can be written as 3 times 8 because 3 times 8 will give us 24. So we shall have 3 times 8 and then minus 100 can also be written in an index form as 10 raised to the power 2. So you have log of 10 raised to the power 2 to the base of 10. So at this very point, realize that we are having the logarithm of two numbers multiplying. Therefore, we can apply the multiplication law for logarithm. And this is the multiplication law for logarithm where you have the log of two numbers multiplying is just the sum of the logarithms of these two numbers. So we are going to spread this. So we have log of 3 to the base of 10 plus log of 8 to the base of 10 minus what? Nowadays, we've gotten log of 3 to the base of 10, which is this. But this one, we don't have it in the estimated number. So you have to break this one down in order to have either this or that. So from here, let's move to this part. We have log of 3 to the base of 10 and then plus, we know that 8 can be written as 2 raised to the power 3. So we shall have log of 2 raised to the power 3 to the base of 10 and then minus log of 10 raised to the power 2 to the base of 10. Now from here we are going to apply the power law. So this is the power law. When you have something of this nature, the power will come and multiply the logarithm. So you are going to apply the power law for this and then that. So you have log of 3 to the base of 10 plus this 3 will come in front. We have 3 log of 2 to the base of 10 minus this 2 will come in front. 2 log of 10 to the base of 10. Now you realize that at the end we are having log of 3 to the base of 10, which is here, log of 2 to the base of 10, which is here, and then log of 10 to the base of 10. So with this, we are going to apply this property, which says that when you have the logarithm of a number to the base of the same number gives us 1. So log of 10 to the base of 10 will give us what? 1. So we are just going to substitute the estimated values for these logs in place of this expression. So log of 3 to the base of 10, the estimated value for that is 0.477. So we are going to replace that with 0.4771 plus 3, and then log of 2 to the base of 10, we have 0.3010 minus 2, this will give us 1. Now when you punch all of this using your calculator, you shall have negative 0.6199, and this is the value for log of 0.24 to the base of 10. At the end, you can always cross-check it with your calculator by punching log of 0.24 to the base of 10 on your calculator, and it is going to give you this very value. Let's look at our next example. So we have our next example. If log of 3 to the base of x is having this value, and then log of 7 to the base of x, the estimated value for that is this very number. We want to find or evaluate log of 27 to the base of x and log of root of 7 to the base of x using these two estimated values for these logarithms. So let's start with the first one. We have log of 27 to the base of x. So realize that we don't have log of 27 to the base of x in these two numbers. So we have to express this or simplify this further so that we can either have this or that. And we know that 27 can be written as what? 9 times 3. So in place of 27, we are going to place 9 times 3. So you have log of 9 times 3 to the base of x. Applying the multiplication law for logarithms, we can write this as log of 9 to the base of x plus log of 3 to the base of x. Now we are having log of 3 to the base of x, which is this one. So we are done with one part, but we don't have log of 9 to the base of x. So we have to simplify further for us to get either this or that. So you have log 9 can be written as 3 raised to the power 2. So we have 3 raised to the power 2 to the base of x plus log of 3 to the base of x. So applying the power law for this, which is this particular law, the power will come in front to come and multiply the log. So you have 2 multiplying log of 3 to the base of x, and then plus we have log of 3 to the base of x. So the rest is just substitution as we said earlier. So you are just going to substitute this in place of that, and then this in place of that. So we have 2 log of 3 to the base of x. We are having this number. So we have 0.5283 and then plus 0.5283. Now when you point all of this on your calculator, you are going to have 1.5849, as easy as ABCD. Let's look at the next one, which is II. So we know that this can be written as log of 7 raised to the power half to the base of x. The radical sign is also the same as a power of half. Now from here we can apply the power law for logarithm, which is this particular law. So the power will come and multiply the whole of the logarithm. So you have 1/2 multiplying log of 7 to the base of x. Now from here we are having log of 7 to the base of x. We are just going to substitute this value in place of that. So you have 1/2 multiplying 0.935 and then 8. And this will give us 0.4679, as easy as ABCD. Let's look at our last example and then we run out of here. Given that log of 2 to the base of 10, the estimated value for this logarithm is this very number. And then log of 3 to the base of 10, the estimated value for this logarithm is this very number. We want to evaluate log of 80 to the base of 10 without using calculator or tables. So you want to evaluate this logarithm expression using these two estimated values. So you have our log of 80 to the base of 10. We want to evaluate this using these two estimated values for these two logarithms. So before we can evaluate this, then we need to express this log of 80 to the base of 10 in the form of log of 2 to the base of 10 or log of 3 to the base of 10 so that we can do our substitutions. So we know that 80 can be written as 8 times 10, right? And that is going to give us what? 80. So we are going to write 8 times what? 10. That gives us 80 to the base of 10. Now from here, applying the multiplication for logarithm, which is this one, we are going to split this and then write this as log of 8 to the base of 10 plus log of 10 to the base of 10. That is for applying the. Now you realize that we are still not having either this or that. So let's simplify further. So we have log of, you know that 8 can be written as well 2 raised to the power 3. So we have 2 raised to the power 3 to the base of 10 plus so from here, applying the power law, the 3 will come and multiply the whole of the log. So we have 3 multiplying log of what? 2 to the base of 10. And then we have plus log of 10 to the base of 10. So from here, we are going to apply this property, which says that when you have the logarithm of a number to the base of the same number, that gives us what? 1. So the whole of this is going to give us 1. So you have 3 log of 2 to the base of 10 plus what? 1. And we know that the estimated value for log of 2 to the base of 10 is what? 0.3010. So we are just going to substitute that. 3 multiplying 0.3010 10 plus 1. Now when you point it on your calculator, you are going to have 1.9030, and this is the value for log of 80 to the base of 10. Once you have your answer, you can cross-check it with your calculator by punching log of 80 to the base of 10, and you have this verified value. This brings us to the end of today's lesson. See you tomorrow. Bye-bye.